Welcome to the session Meter Bridge. In this session, we are going to find the resistance of the given wire, each specific resistance, and we are going to verify the laws of resistances using meter bridge. The apparatus we are using in meter bridge experiment is battery, plug key, resistance box, high resistance, galvanometer, meter bridge, jockey, screw gauge, and connecting wires.
Meter bridge consists of 3 copper strips M, N and D of negligible resistances fixed on a wooden board. Between M and D there is a gap G1. Between N and D there is a gap G2. A metal wire is joined between two ends P and Q with the help of a binding screws. The metal wire is stretched over a meter scale. A battery B is connected to P and Q through key K. In gap G1, an unknown resistance is connected. In gap G2, a known resistance box is connected. In the middle strip from point D, a sliding jockey is connected through high resistance and galvanometer.
After connecting all the connections according to the circuit diagram, exclude the high resistance from the circuit. Now, switch on the key and take the jockey. The jockey now, when pressed at the left end of the wire, that is P, the galvanometer deflection will be towards right. Now, press the jockey at the other end, that is right end of the wire Q. The deflection in the galvanometer will be towards left. Then we say the connections are correct. Then include the high resistance to conduct the experiment to determine unknown resistance. To determine the resistance of the given wire, consider the wire in the gap G1. Now, switch on the battery, take 2 ohm resistance in the resistance box, take the jockey and press it at different points on the manganese wire. Now, for a length 20.3 centimeters, we are getting zero deflection in the galvanometer. It means The bridge is said to be balanced for this length 20.3 centimeter. Consider it as L1. The series combination of the two resistances is considered in the left gap of the meter bridge by connecting one end of the wire to the end of the next wire. The ends of the two wires are connected in the left gap and switch on the battery now. Take 2 ohm resistance in the resistance box. Take the jockey, press it at different points on the magnet wire till we get zero deflection. Here, the zero deflection in the galvanometer is identified for a balancing length of 34 centimeter. In the parallel combination of the wires, the two wires are twisted and connected in the given gap G1, that is left gap. Switch on the battery now. Take 2 ohm resistance in the resistance box. Consider the jockey. Press it at different points on the magnet wire till we get the balancing length. The balancing length obtained in this parallel combination of the two wires is for 9.6 centimeters, that is L1. Here we are going to determine the specific resistance of the material corresponding to the second wire, which is having resistance R2, from the formula R is equal to rho L by A. Rho is the specific resistance of the material, L is the length of the wire, and capital A is the area of cross section of the wire. To find the area of cross section, we have to determine its diameter first. To determine the diameter of the given wire, we have to consider a screw gauge.
Let us describe the screw gauge. A screw gauge consists of U-shaped metallic frame. This metallic frame consists of a hollow cylindrical nut on one side and metal stud S on the other side. There is a screw S2 in the cylindrical nut. The screw S2 carries a milled head H. attached to the cap C. This head H is rotated with the help of device D. When it is rotated, the screw moves to and fro in the nut. The outer surface of the long nut consists of a thick horizontal line P parallel to the axis. This line is called the index line or the pitch scale. The circular periphery of cap C consists 100 equal divisions, and this is called head scale.
Keep the wire between the two studs and rotate the screw till you hear the sound in the screw. Now, first we have to take the pitch scale reading and we observe one division is moved. So the pitch scale reading is 1 millimeter. Now, the head scale reading will be taken according to the coincidence with this index line. Here it will be 4. Thus, we conclude this experiment after finding the resistance of the given wire, the specific resistance of the material of the wire, and verifying laws of resistances in series and parallel combinations.